Hello everyone, now we will discuss about data preparation phase to model the data. Here what is the data preparation phase to model the data? Data preparation is like setting the store for a play. Before you can build a model, the data must be cleaned, structured and paginated to give accurate result. This step ensures that the data reflects reality, avoids bias and supports meaningful insights. Let's explore how we can prepare data effectively for machine learning. Data preparation is the process of cleaning. Here you can see in PPT we can see data preparation is the process of cleaning. First data cleaning, second data transformation, third data partitioning, fourth is balancing. Next we will talk about how to partition partition the data in Python. How to partition the data in Python. Partition is about the splitting your dataset into training and test set, ensuring your models learns from one part and is evaluated on another. In Python, we use tools like train, test, split to make this process seamless. This step is vital to avoid over overfitting and to test the model ability to generalize the unseen data. Now let's see the code. We have how to partition the data using Python. From sklearn.model selection, import train test split. Import pandas as PD, sample data, data, feature 1, feature 2, target, and df equals to pd dot data frame data. Partitioning the data, x equals to df feature 1 feature 2, y equals to df target, x train x test, y train y test equals to train test split, xy comma test size equals to 0.3, random state equals to 42, and any size. Now we have now we have to print training sets from the next line, and x train print test set test. Now we will run our code. We have training set feature 1 feature 2, test set feature 1 feature 2. Now we will discuss about how to balance the training dataset in Python. When dealing with the imbalanced dataset, your model might ignore minority classes. Techniques like oversampling or using like uh, tools like Smooth can balance the dataset, ensuring your model treats all classes fairly. Now we will see at our code or how to balance the training dataset using Python. We have from imb learn.over sampling import smooth import panda as pd, sample data equals to features target, df equals to pd dot data frame bracket data. Here we are balancing the data using smooth, setting k neighbors to a value less than or equal to the number of minority class samples. Here the number of minority class target equals to 1 is 3. If k neighbor is not specified, default value is 5, which is larger than the total minority samples. Here x equals to df features, y equals to df square brackets target, smooth equals to smooth, random state equals to 42, k neighbors equals to 2. So changed here. X resampled y resampled equals to smooth dot fit resample xy. Now we will print our code. Here we will print balance data set pd dot data frame bracket x resampled column features dot assign target y target equals to y resampled. Now we will run our code. Balanced data set. Here you can see features and target we have. Next we will talk about how to build card decision tree in Python. Card decision tree is split data based on the Guinea index, creating clear and interpretable decision path. With Python decision tree classifier, you can easily train and visualize these trees to classify data effectively. Cart classification and regression tree is a popular decision tree algorithm that splits the data sets based on the Gini index or variance. For regressions, it is easy to interrupt and effective for classification tasks. Now we will look at our code, how to build cart decision tree using Python. From sklearn.tree import decision tree classifier. From sklearn import tree, import pandas pd. Sample data, we have data equals to feature 1, feature 2, target, and df equals to pd dot data frame data. Train a cart decision tree. Now we will train the cart decision tree. X equals to df, x equals to df target, cart model equals to decision tree classifier, and cart model dot fit x comma y. Now we will visualize the tree dot plot tree bracket cart model. Here we will run our code. As you can see, our tree look likes x equals to 0, and this is our output. Now next we will talk about how to build C5.0 decision tree in Python. C5.0 is an improvement over cart, offering better accuracy, smaller trees, and support for boosting. While not natively available in scikit-learn, it can be accessed through external libraries or approximate using similar algorithm like C4.5. Here C5.0 is a more advanced version of cart, providing smaller and more efficient decision tree. While native libraries for C5.0 are limited, the approach can be implemented through approximately or external tools. Now we will look at our code, how to build C5.0 decision tree using Python. So first placeholder for C5.0 implementation, print C5.0 implementation can be achieved using external libraries like sklearn porters or by translating a C4.5 like approaches. Now next we will talk about how to build random forest in Python. Random forest is a ensemble learning method that builds multiple decision tree and averages their predictions for better accuracy and robustness. It reduces overfitting and handles large data set as well. Random forests are a combination of multiple decision tree working together to give more stable and accurate predictions. With Python's random forest classifier, you can create these models quickly, leveraging their ability to handle complex dataset effectively. Now let's look the code, how to build random forest using Python. From sklearn.ensemble, import random forest classifier, import pandas pd. We have sample data equals to feature 1, feature 2, target, and df equals to pd dot data frame data. Now we will train a random forest. X equals to df feature 1, feature 2, y equals to df square bracket target, rf model equals to random forest classifier, rf model dot fit x comma y. Now we will print random forest model train. Now we will run our code. Here you can see random forest model trained. Thank you. I hope you understand the topic.